6.7. All right. So first off, can be factored. Are there two numbers that multiply to give me 10 that differ by 3? What numbers make 10? 2 and 5. Do they differ by 3? Oh, they do. Okay. So it factors. Since it factors, we don't have to worry about quadratic formula. We don't have to worry about a table. Which one do we want to be negative? We want negative 3. Which one's negative? The 5 or the 2?
Wait, what?
So since it factors, we want negative 3 in the middle. Which number do we want to be negative? The 5 or the 2?
2.
Do we want 5 minus 2 or 2 minus 5? You get negative 3.
5 minus 2.
5 minus 2 is negative 3.
No, I mean 2 minus 5.
We want 2 minus 5. We want positive 2 minus 5. So that gives me x equals 5 and x equals negative 2. So right off the bat, I have 2 points. Now, there's 2 ways to go about. If you actually know the x-intercepts, there's a shortcut. Okay? You can actually find the axis symmetry from just finding the middle of those two. You don't have to do the opposite of d over 2a. You can just find the middle. 5 plus negative 2 divided by 2. Okay, so what is that? What's 5 minus 2? 3. And 3 divided by 2 is? Yes, 3 divided by 2. It is a decimal. You have calculators. Find it. 1.5. So the vertex is at 1.5 comma something. Okay? So, plug that in. On your calculators right now. Put it in parentheses, 1.5 squared minus 3, parentheses, 1.5 minus 10. Negative 12.25. Okay, negative 12 1/4. So that's going to be, here's 1, here's 2, it's going to be in between here. This is 10, so it's going to be approximately down here. Okay, no big deal. Just approximate. Now, what's my y-intercept? We do got one.
It's -0, negative 12.25.
That's the vertex. I'm asking for the y-intercept.
Yeah, I know.
Negative 10, right here. Okay? So, that gives me that. What's my axis symmetry? X equals what?
1.5.
1.5. Okay, the y-intercept we know is at 0, negative 10. What are my x-intercepts? We already have them. 5 and negative 2. You can also put 5, 0, negative 2, 0. Doesn't matter. Pops up either way. 1 point, that's the vertex right there. The x-intercepts are these points right here that hit the x-axis. Okay? Now the only tricky one is the mirror image for this one. Okay? How many spots away is this from here? No. What's right here? 1.5, right? So 1.5 from here is what? 3, right? 1.5 doubled is 3.
Yeah.
Okay? So the other little point is right there at 3. 3, negative 10. At that point, you have 5 dots. Just a little bit. There's your part, your parabola. So the domain, again, is all real numbers. The range, is it greater than or less than? Greater than or equal to what number? Negative 12.25. It's starting at negative 12.25 and going up, greater than. In behavior, again, it's just going up and up that way. Okay, we're going to skip 2 because we had enough practice with that. And real world problem, classic parabola problem. Emilio is competing in the javelin throw. The height of the javelin can be modeled by this equation, where y represents the height of the javelin in feet and x represents time. Often you'll see actually T's and H's here, you know, but that's fine. So x is time. So graph the path of the javelin. Well, we got to find the highest point, so we got to identify A, B, and C first. So what is A? Negative 16. What's B? 64. What's C? 6. So x equals the opposite of 64 over 2 times negative 16. Type that in your calculator. Find out what the x coordinate is. What's the vertex? What is it? No. Negative 64 divided by 2 times negative 16. Right. If you're typing it in like that, you're going to get the wrong answer. So the 2 means in how long will it be at its highest point? 2 seconds. So in 2 seconds will be at the highest point. We got to find out what that is. So we have to plug this 2 in here and here. So go ahead and do that now. On your calculators, type that in. Okay. So the vertex is at 270. So let's put a dot there. 2 up here at 70. It's being thrown up in the air, coming down. Okay. What is the y-intercept?
0, 0 and 6, negative 16. I mean 0 and 6, my bad.
Okay. So the y-intercept is at 0, 6. That is right down, you know, you have to put this thing hard to see, but like down there, right? That's where it's starting from. Okay, that's where he is. In other words, if the dude's like, you know, 5.5 feet tall, by the time he releases it, you know, it releases from his hand at about 6 feet in the air, off the ground. So if he was 5, you know, maybe 5 feet tall, I don't know how tall you have to be with your arm, whatever. But he released it at 6 feet. Okay? So depending on your height, it would change. But this number here, that number is the starting height. It will always be the starting height. So the y-intercept is the starting height. That's where it starts to graph. Now, what's the maximum height? Whoops. We just said it. 70 feet. You just said it right here. Right here. Oh, yeah. So 70 feet. Now it says, where will it hit? How? Use the graph to estimate how long the javelin was in the air. So when's it going to hit the ground? In other words, when will y be 0? When will the height be 0? When will it hit the ground? Stick in the ground. Okay. So we're going to come down here for this because there's not room for it. Well, we'll put that up here. We can't factor it, so we have to do the opposite of b plus opposite of b plus or minus square root of b squared minus 4ac all over 2a. So what's my a? Okay. A again. Negative 16. And that goes here too. What's my b? 64. That goes here. And that goes here. And then my c is 6. That goes here. Just to save time, when you do this, you get two answers. Negative 0.09 and 4.1. Let's just say it's negative 0.1. 4.1 negative 0.1. Which answer does not make sense? Why? You can't go back in time. Right? So, now, but think about it. Let's think about this. Isn't 6 feet really close to the ground? And negative 0.1 is really close to here. In other words, if we completed this arc, like if we completed this right here, it would take about negative 0.1 to hit back on the ground. Like, so if I dropped it, how long would it take to drop? Negative 0.1. Theoretically, but it doesn't happen. So 4.1 is approximately where it hits, so we just do that. That's our graph. No arrows, because it's stopping. So our answer here is about 4.1 seconds. Now, where will it be in 3 seconds? We just plug in 3 to our original equation. So everybody crunch that. 54 feet is correct. Plus, if you look here, here's 3 seconds. That makes sense. 54 makes sense according to the graph. So 54 feet. Okay, one more. That one's just good. Oh, it is there. Okay. You guys have that already drawn on there, right?
Yeah.
Okay. Okay, so dude shot an arrow in the air. Okay. Notice what I was talking about before, H and T. This one actually has it. So, where did it get shot from? How high? No, technically, this is like I said, it doesn't. Where did it start? No. What did I say was always the starting point? Look at the previous page.
That last one was 6.
It's 6. This is the starting point, right? C is the Y-intercept, is also the starting point. So 6 feet. Okay, so for example, I'm about 6'3", so 6 feet is about here. So if I release an arrow from right, at my head and released it, okay, 6 feet. That's the starting point. That's where it left the bow. Now, from the graph, estimate the maximum height. We're not doing all the math here. Just estimate about what is the highest point.
20.5.
21 feet. Something like that. Yeah. Because you're looking at about, 3 seconds, 0. Halfway would be 1.5. So you're talking about somewhere around there. So 21 feet, 22 feet, that's fine. We're just reading the graph. Where is it at about 2 seconds?
Like 18? Yeah. 18, 17, 16.
Okay. That's about what it is, right? But it does say calculate. So what are we going to do with 2? There you go. Negative 8, 2 squared, plus 22, times 2, plus 6. You're putting 2 into that equation. So look, save yourself trouble. Negative 8 times 4. Plus 22 times 2 plus 6. Right, so you guys estimated about 18 feet and it ends up being 18. To do this? No. How long it's in the air is how long until it hits the ground, right? So that's the quadratic equation again. Opposite of b plus or minus square root b squared minus 4ac all over 2a. What's my a? Negative 8. Again. Okay, what's my b?
22.
And what's my c? 6 again. Okay, so let's crunch that. You're right. You should have negative. You should have 676 underneath the radical. Okay, if you do it right, because this negative times negative ends up being positive 32. So you do 22 squared plus 32 times 6, so you get 676. Now we're going to do 2 different problems. Negative 22 plus square root of 676, whatever that is, divided by negative 16. Negative 22 minus square root of 676 divided by negative 16.
I got negative 0.0.
Because it's the opposite of b.
I got negative 0.
So negative 22 plus the square root of 676 divided by 2 is 2. Because guys, the square root of 676 is 26. So this is going to be negative 22 minus 26 divided by negative 16. Negative 22 plus 26 divided by negative 16. Yeah, this should be negative 0.25. You're right. The first one should be negative 0.25, which again, why did we throw this out? Why did we throw that out?
Because you're negative.
You can't go back in time.